Good morning, everyone. For those of you who don't know me, let me introduce myself. So my name is Scott Oakley, and I'm the Technical Manager here at Glasscorp. The subject of today's webinar is an introduction to structural glazing. I understand that some of you will already be doing structural glazing, so a lot of what I cover today will serve as more of a refresher course for you, while some of you may not have done much or any structural glazing before, in which case I hope today's webinar serves as a helpful introduction. A large part of my role at Glasscorp is involved in coordinating the different project and sample submissions that are a requirement for Dow structural glazing projects. I'm also heavily involved in the in-factory and on-site testing and QA requirements for structural glazing projects. Just some housekeeping before we jump into the presentation. So for the presentation, I ask that you please turn your microphones off so there's no background noise. If you have any questions during the webinar, please send these through using the chat function. And if I'm not able to respond in the moment, we should have time at the end to get to those. And if there's any questions that I'm not able to answer today, I'll make a note to follow up after the webinar. This presentation is being recorded, and we will be looking to make this recording available along with the previous webinar on general sealant application. We'll keep you posted on this. I'm just going to switch off my camera now, and we'll jump into the presentation. Just to summarize the agenda for today, so we'll start off with an introduction to structural glazing systems and joint designs. I'll then cover the Dow range of structural glazing sealants that we offer. After this, I'll talk about the project support and technical services we offer through Dow. And after that, we'll discuss some real-world structural glazing, starting off with important quality control considerations and then practical substrate preparation and sealant application. I'll finish off with a comment on structural glazing warranties before some time at the end for any questions. There are many different types of structural glazing systems available. Common to all these systems is that they utilize structural silicone sealant to attach glass or another panel material to the structure of a building. In this section, I will discuss some of the more common system types before we look at more detailed structural joint design. The most common system used in New Zealand is what we call four-sided structural glazing. Very simply, in the system, all four edges of the glass are supported by structural silicone. Four-sided structural glazing systems are typically fabricated in a factory setting, with the completed frames then being erected on site. Another common system used is two-sided structural glazing. This is where two of the four sides of the glass are supported by structural silicone, with the other two sides being either mechanically supported or not structurally supported by a frame. Two-sided structural glazing systems are either fabricated in factory or on site. Now let's take a look at the different elements that comprise a standard structural joint design. Firstly, we have here what is called a split joint design. Running through the different components, you have your aluminium frame, the spacer tape. We supply high density PVC foam tape suitable for structural glazing. This is designed to support the weight of the insulated glass unit, or IGU, which rests on top. Next, you have your structural silicone applied against the spacer tape. This is what is being used to bond the IGU with the aluminium frame. Next, you have your backing rod. We supply polyethylene backing rod, over the top of which you have your weather seal. In real-world application, it's quite common for the same product that's being used as the structural silicone seal to also be used as your weather seal. Now, the reason we call this a split joint design is because the structural joint is separated from the weather seal on the glass edge. This tends to be the preferred structural joint design, especially when structurally glazing IGUs. A key reason for this is that it's not desirable to have either the structural joint or the weather seal come into contact with the secondary seal of the IGU. When this happens, the joint movement capability becomes limited and the long-term integrity of the IGU can be compromised. Here we have another example of a split joint design, however, with a single pane of glass only. The principle is the same with a separate structural seal and weather seal, this time separated by just the spacer tape. Another popular joint design is what we call the L joint design. This is a simple design where you have your frame, the structural spacer tape on top of which sits the glass, and finally the structural silicone. In an L joint design, the structural joint and weather seal form one continuous seal around the edge of the glass panel, creating this L shape. The design is not recommended for installing IGUs for the reasons I previously mentioned. In this example, we have a single pane of glass, so the risk of contact with the secondary seal isn't a concern. One potential issue with this type of joint design is that sometimes for particularly large and deeper joints, they could be quite hard to fill, and it could be more difficult to achieve that complete joint fill. Now that we know what components go into a structural joint, let's look at the considerations that must be made when designing a structural joint and some of the terminology that you should be familiar with. First, the structural bite. This is the minimum width or contact surface of the silicone sealant on both the glass panel and the frame that is required to hold the glass in place. In order to determine the structural bite, there is a structural bite calculation that we use. The standard calculation takes into account the size of the windows being structurally glazed and the maximum wind loads that the window may be subjected to. Secondly, we have the glue line. The glue line is the thickness of structural sealant between the frame and the glass panel. The glue line is set by the thickness of the spacer tape. So we carry the structural spacer tape in two standard thicknesses, 6mm and 9mm. Now that we're familiar with the structural bite and the glue line, I'll briefly run through some essential design principles that must be followed when designing a structural joint. Both the structural bite and the glue line thickness must be at least 6mm. The structural bite must be equal to or greater than the glue line thickness. The bite to thickness ratio should be between 1:1 to 3:1. And finally, the joint must be designed in such a way that it can be applied easily using standard sealant application procedures. Now, the basic guiding principles behind these points are that the structural joint must be of a minimum size so that an applicator can reliably apply the silicone joint and achieve that specified joint dimension. And the principles guiding the bite to thickness ratio relate to the structural bite being able to tolerate any potential movement or stresses that it may be subject to. When we're talking about stresses that the silicon may be subject to, one of the most obvious factors that we need to consider is wind loads. As I mentioned previously, the minimum structural bite in a silicone joint is directly proportional to the maximum wind load pressures it will be subject to. Wind pressures acting on the facade are transferred through the structural sealant to the structure of the building. This image shows a somewhat exaggerated view of how the structural silicone is designed to deform and move when subjected to wind loading. Another important term you should be familiar with is that of a supported glass design. Now, what do I mean by supported design? In standard structural silicone joint designs, the weight of the glass is supported by an aluminium fin. The glass rests on silicone setting blocks, which are applied before the panel is completely structurally glazed. We strongly recommend using silicone setting blocks, which we supply, as we know that these are fully compatible with Dow structural glazing silicones. Now, the alternative to a supported glass design is an unsupported glass design, or what is often referred to as a dead load design. In a dead load design, the glass weight is supported only by the structural silicone, as you can see in the image here. If a glass panel is subjected to dead load, then the calculation we use to determine the structural bite is different, with the weight of the panel being considered as the primary stress factor as opposed to the wind load. Now, in this next section, I'll talk about some of the structural glazing sealants which we offer through Dow. Each product is developed and tested for specific applications, and they should only be used where intended. Firstly, Dowsel 983. This is a two-component, fast-curing structural silicone. It's applied in factory settings and requires the use of a mixing pump to mix the separate base and catalyst components for application. Dowsel 983 has a 25% movement capability, and when used in factory structural glazing, it's often used for both the structural seal and the weather seal. Dowsel 795 is a one-component structural silicone often used for on-site structural glazing applications. It's applied using your standard cartridge or sausage guns. Being a one-component product, it will inherently take longer for full adhesion to develop. As such, when used for structural glazing applications, temporary fixings or fasteners will typically be required to hold the panel in place while the sealant is developing full cure and adhesion. It has a 50% movement capability, and we supply it in black, gray, and white colors. Dowsel 121 is a two-component fast-curing structural silicone. We supply it in a 400 ml double cartridge, so that's made up of one 200 ml cartridge of base and one cartridge of catalyst. These are mixed at a 1-to-1 ratio. That's where the product gets its name, 1-to-1. Dowsel 1-to-1 requires a pneumatic or electric gun to dispense the product. We supply both of these options. The product is ideal for situations where fast curing of sealant is required and a two-part glazing pump isn't practical or available. So, for example, on-site structural glazing or on-site repairs where it may not be feasible to have scaffolding or temporary fasteners holding panels in place for extended periods of time, and you just need a fast curing product to get in and get the job done quickly. Finally, in this section, I will mention Dowsel 791. I'll point out Dowsel 791 is not a structural silicone. This is our premium weather sealing product, so you could think of it as part of the family of wider silicone facade products. Dowsel 791 has a 50% movement capability. We supply it in 500 ml sausages in black, gray, and white colors. Now, in addition to supplying the structural silicone and associated equipment and materials, we also work closely with Dow to offer comprehensive technical and project support. So in this next section, I'll just run through the different processes involved in a typical structural glazing project and the different services that through Dow we're able to offer. Starting off in the design stage, before structural glazing has begun, Dow will review all the relevant structural joint and project details before issuing a formal approval for their sealants to be used in the proposed design. This approval is what we call a print review. To start with, for each structural glazing project, our customers will complete and submit to us a project details form. This is a simple form which includes specific project details such as the project name and the street address, details pertaining to the structural bite that's being used. So this will allow Dow to review the structural bite calculation and verify that the nominated bite is sufficient. Nominated sealants and the estimated usage. This just gives us an idea on the size of the project and allows us to ensure the necessary stock will be available when structural glazing begins. And finally, any non-standard details. So for example, if there are any panels in dead load or if there are non-vertical panels, for example, structural glazing of skylights, something like that, then a different structural bite calculation is used, and this will all be verified by Dow. In addition to the project details form, we also need to submit relevant detailed drawings to DAO for review. They will verify that the structural joint designs being used meet the minimum structural bite requirements and adhere to those essential design principles that I mentioned earlier. The types of drawings we would submit include typical mullion transom details, typical elevations and floor plans, and any non-standard details. It's very important that all drawings provided are clearly labeled and dimensioned. The drawings on the right are a good example of a clear and detailed joint design drawings that we're looking for, where all the components are clearly labeled and dimensioned. Having reviewed the submitted project details alongside the relevant drawings, DAO will issue a written print review. So this comes in the form of a letter which specifies their approval of the proposed design, the joint dimensions, and the sealants to be used. The print review will also include comments and general recommendations on correct structural glazing methodology that should be used. Now, sealant adhesion is one of the most critical components of a successful structural glazing project. For each structural glazing project, DAO need to verify that adequate adhesion can be achieved. And this is done through formal lab testing. So firstly, labeled representative samples of the relevant substrate. So for example, the aluminium profiles and the glass are sent to us. We then forward these through to DAO laboratories for formal adhesion testing. DAO perform adhesion testing to an adapted ASTM C794 standard. In this testing, DAO will test for adhesion with whatever cleaning methods we propose, and they will also test for adhesion with and without the use of primers. At the conclusion of testing, DAO will provide a specific product recommendation in the form of an adhesion test report. This report will contain information on which sealants achieved adequate adhesion and what cleaning primary methods should be used in order to achieve good adhesion. And again, it will also include just general recommendations on substrate preparation and sealant application that should be followed to ensure good adhesion is achieved. The other type of lab testing that is done as standard is compatibility testing. When glazing accessories that are incompatible are used, they may cause the sealant to discolor, or in severe cases, they may even compromise the adhesive performance of the sealant. Labeled representative samples of the relevant substrates. So in this case, we're looking at things like setting blocks, the glazing tape, and the backing rod are sent to us, which we then forward through to DAO for formal lab testing. And we would send these together with the samples for adhesion. DAO then perform compatibility testing to an adapted ASTM C1087 standard. The photos here just provide an example of what incompatibility can look like. It often presents itself in the form of light or severe discoloration of the sealant after exposure with a particular substrate. Once compatibility testing is concluded, DAO will issue their product recommendations in the form of a compatibility test report. The simple report will verify which components are compatible or incompatible with the sealant products tested. You might be thinking, if the same glazing components are used in every structural glazing project, do they need to be tested for compatibility each time? If we already know that they are compatible, the short answer to this question is yes. Each individual project requires specific test reports. This is just part of the DAO standard process, and it's a requirement in order for the project to be issued with a structural glazing warranty, which is a point I will come back to at the end of this presentation. This next section now, comprehensive quality control is the most critical element for a successful structural glazing project. There are several important QA procedures which DAO recommend depending on the product being used. I'll run through a few of these now. The butterfly test is a test that is done on two-part sealants. The purpose of a butterfly test is to determine if adequate mixing of the sealant, base, and catalyst is being achieved. Just running through the steps. A piece of paper is folded in half before a bead of sealant is applied down the center fold. The sheet of paper is then pressed back together, compressing the sealant into a thin film. The paper is then pulled apart and the sealant is inspected for any signs of poor mixing. Properly mixed sealant should be uniform in color with no marbling or streaking. These images show a butterfly test both before and after being compressed. The image on the right shows a good example of what we want to see, which is mixed sealant that is uniform in appearance with no streaking visible. The snap test is an important test for two-part sealants, which is used to determine if the sealant is properly curing according to its specification. The basic steps involved. Firstly, fill a small container with mixed Dialsyl 983 sealant. Usually a small paper or plastic cup is used here. Place a small stick into the sealant and record the time. This will be your start time. Every few minutes, pull the stick out of the sealant to observe how it's curing. As the sealant starts to cure, it will start to become stringy. Once the sealant tears cohesively and snaps back once it's pulled, the snap time has been reached. Note down the snap time in your QA logs and on the sample itself. Different factors will affect the curing speed of a two-part sealant. In cooler, less humid conditions, the sealant will take longer to cure through, which will result in longer observed snap times. The base to catalyst ratio you use will also influence the observed snap time, with mixes containing more catalyst curing faster than those containing less. In this slide, we have examples of a completed snap test. As you can see, the temperature and humidity and date when the test was done have been noted down on one side. The other side has the start time and the snap time recorded on it, with a snap time of just over 50 minutes observed here. It's important that both the base and catalyst batch numbers are also recorded, if not on the physical sample, in a maintained QA log. Peel adhesion testing is the most effective test to verify sealant adhesion to a substrate. This is an important test that should be done daily. We suggest that this test is done on a hidden section of frame to ensure that we're testing the actual substrate, excuse me, that is being used on the project. The steps involved are simple. Clean and prime the substrate as per the specification. Apply a bead of sealant and tool it to form a continuous strip approximately 200 mils long. After the sealant has cured, cut and grasp a tab of sealant. And finally, pull the sealant tab at a 180-degree angle and note down the failure method observed. We want to see cohesive failure, as shown on the left image here. That is the sealant tearing within itself, as opposed to adhesive failure, shown on the right, which is what happens when the sealant pulls cleanly away from the substrate, as shown here. These images just show a test layout done on the side of the frame on the left. The image on the right shows a strip of sealant being pulled in the adhesion test. Now that we've covered some common QA tests for two-part sealants, let's look at some tests for one-part sealants. The first of these is the skin over time test. The purpose of this test is to check the sealant working time and to ensure that sealant is properly curing. I'll run through the steps. Start by spreading a thin layer of sealant up to a couple of millimeters thick on a polyethylene sheet. Glad bags work great for this. This is what we use for our in-house testing. Essentially, you just need a surface that the sealant is not going to stick to. Every few minutes, touch the sealant film lightly with your finger. Finally, when the sealant no longer sticks to your finger, the skin over time has been reached. Check to ensure that the sealant is skinning over appropriately according to the TDS. If the time taken for the sealant to skin over is excessively long, that may indicate that the sealant is outside of its usable shelf life, or that it's being stored at an excessively high temperature. Like the two-part sealants, the curing rate and the observed skin over time will vary with temperature and humidity. When the temperature and humidity is higher, the sealant will show a tendency to skin over and cure faster. Another simple test following directly on from the skin over time test is the elastomeric test. This is done to check that the sealant is demonstrating typical elastomeric properties. Allow the sealant to cure for at least 24 hours or longer if required, and then peel the cured strip off the sheet. Slowly stretch it to determine whether it has cured to its normal elastomeric properties. If the sealant is not cured properly, or if you see irregularities, such as the sealant being very stretchy or very brittle, don't use the material and let us know. Deglaze tests are a method of quality inspection used to confirm sealant adhesion, joint fill, and quality on actual structurally glazed production units. The important elements that are assessed in a deglaze test include the following. The dimension of the structural bite and glue line thickness is checked to ensure that it matches the approved dimensions in the print review. The adhesion of the structural sealant to the frame and the glass is checked. And these first two things are the two most important factors that are checked in the deglaze test. Others include the uniformity of cure and the quality of the sealant mix, any air entrapment or bubbles that may be present in the sealant, and finally that substrate details, what we're testing, match the detail and samples that have been previously provided. Formal deglaze tests are carried out at a specified frequency prescribed by Dow. The first deglaze test is done on one panel of your choice from the first 10 that are structurally glazed. Note that I said panel and not frame, not as a single frame may be comprised of multiple pieces of glass. In this instance, the fifth panel structurally glazed was selected and cut out for a deglaze test. The second deglaze is done on a panel from the next 40 structurally glazed, or simply put anything from panel 11 to 50. The third deglaze test is done on a panel from the next 50 structurally glazed, or anything from panel 51 to 100. And then for the remainder of the project, just one in every 100 panels structurally glazed is used for a deglaze test. The reason we have more deglaze tests set at the very beginning of the project is so that any potential systemic issues are identified and addressed as soon as possible. These next photos just show some examples of good and poor joint fill. So on the left, you see the silicone is applied right up against the spacer tape, which is what we want to see. The example on the right, you can see clear gaps and voids in the structural seal where complete joint fill hasn't been achieved. These are just examples from deglaze of good adhesion versus poor. So on the left, that's what we typically see. No silicone is coming off the frame. The photo on the right shows adhesion loss, which is what we really don't want to see. In this final section, I'll cover important points relating to correct surface preparation and sealant application. Correct substrate cleaning is important for standard sealant applications. In structural glazing applications, it's critical. The most common cause for adhesion failure is poor preparation and cleaning. Priming is not a replacement for good cleaning. Recommendations on the appropriate cleaner to be used will be detailed in the adhesion test report issued from Dow. From our own experience, we recommend isopropyl alcohol or IPA to be used to clean glass, and Glasscorp FB7803 cleaner for powder-coated and anodized substrates. We recommend using the two-cloth cleaning method on all surfaces where sealant is to be applied. I'll run through this now. The two-cloth cleaning method comprises two easy steps. Firstly, dispense your cleaner onto a clean, white, lint-free cloth. We supply safety blowback bottles to easily dispense solvent, cleaner, and eliminate any risk of cross-contamination back into the bottle. Use this cloth to vigorously rub the substrate. The solvent will lift any waxes, dirt, and contaminants from the substrate, which will then be held in suspension. The second cloth is used to remove suspended contaminants from the substrate. So immediately after the first step, using a new clean cloth, wipe the surface vigorously to remove contaminants. Check the cloth to see if it's picked up all the contaminants, continuously rotating the cloth and wiping down the surface until no remnants left. Ensure that the solvent is removed with the dry cloth before it evaporates, or the cleaning won't be as effective. Now that we have a nice clean surface, the next point to consider is priming. A primer is an adhesion promoter. There are some fundamental guidelines when it comes to using primers. Primers should be applied according to the instructions set out in the product TDS. So make sure you allow the required time for the primer to dry and the solvent content to evaporate before applying the sealant. While you need to allow the required time before applying sealant, you also need to make sure that you're not leaving primed surfaces exposed for too long either, as there is a risk of surface contamination. Finally, it's important that you don't overprime. So when you see a chalky, powdery residue left on the surface, that may be a sign that too much primer has been applied, or that the primer has expired and is no longer suitable for use. In either case, there is a risk that this will inhibit adhesion and not help it. In my previous presentation on general sealant application, I mentioned that the use of primers is generally not recommended unless absolutely required to gain adhesion. Structural glazing, being a high-performance application, is a bit different. It's common for primers to be used to ensure adhesion, especially for in-factory structural glazing, where it's standard. The two standard primers that we provide for structural glazing applications are Dow Primer C for powder-coated substrates and Dow 1200 OS, which is standard for anodized aluminium, among other substrates. Important note, do not prime glass surfaces. Glass does not need to be primed. Now that our substrates have been cleaned and primed, we are ready for structural glazing. Here I will run through a brief overview showing how the different components come together. Just note, I'm not claiming this to be the only correct glazing sequence or methodology. This is just being given as an example. So firstly, the structural spacer tape is positioned. Then setting blocks are placed into position. These can be used to correctly align the glass panel in the frame. The glass is placed on top of the structural spacer tape. At this point, masking tape may be applied to the glass edges. And finally, structural sealant is applied and tooled off to ensure good joint fill or wet out. Let's just take a closer look at the actual sealant application. So in this example, just for clarity, we have a single glazed panel being structurally glazed into an L-joint style structural joint. The application nozzle is inserted into the base of the joint to allow the sealant to be gunned directly into the structural joint, so complete joint fill can be achieved. This shows the direction that sealant will tend to flow when being applied, and the parts of the joint where complete joint fill can be difficult to achieve. Attention should be paid to this. To ensure complete joint full, apply sealant in a continuous operation. Positive pressure should be used, and the sealant should be tooled off. And finally, after the sealant is applied, masking tape can then be removed. Finally, as I mentioned before, I just wanted to make a point about warranty. So Dow offer a 15-year structural glazing warranty, which is issued on a project-specific basis. To obtain a warranty, the following steps must be completed. Dow must approve in writing the structural glazing joint design. So that's the steps involved in the print review, which I talked about earlier. Dow must approve all the materials which contact their structural glazing silicone for adhesion and compatibility. So that's our 2 lab reports, which we do before the project starts. A record of completed Deglaze tests must be submitted to and approved by Dow. And then finally, a complete record of batch numbers and the total quantity of product used must be provided. That brings us to the end of the webinar. So thank you very much for your time. I hope you were able to take something from this. It was just a brief sort of basic introduction. So there's definitely a lot that we didn't have time to cover, which we might do at a later stage. We do have a few minutes now for questions if anyone had anything to send through. Otherwise, know that we're always here to help for your day-to-day project requirements and general inquiries. Your account manager or rep is a great first point of call. And then for any more involved technical inquiries or requirements around testing or warranties, I'm happy to assist.